Hello and welcome back to Speed Freak Garage, home of power sports on YouTube. So you're probably wondering, what is this square thing? Well, we have a hole here and here to simulate our Heim joint connection, and then we have a hole here to simulate our ball joint connection. And then we let the computer do the heavy math. In this case, I've already done it. So you can see that this U shape is the same U shape that they use on off-road vehicles with very strong tubular control arms. And then also, because this one is off-center, it has added this little strengthening support here. Now, unfortunately, if I tried to make a control arm like this, my wheel would hit the control arm. So we're going to have to design a completely different style, which sucks. We won't be able to make an optimal style, but we'll try to get close. So the first thing that we're going to do, we're going to close this and start a new one. We're going to draw the wheel first. So we've got a 14-inch barrel, and then we've got a 25-inch tire. Okay, so now what we're going to do is we're going to extrude this out, and we're about 2-inch offset from the center of the ball joint. So 2-inch. Then we are going to create this is kind of hard. We are going to create a point at center of circle right there. So we now have a work point. Okay. Then we need to and it's kind of funny, I don't remember how wide the original wheel was. I believe it was a 7-inch. So we're going to do 7-inch. 7 minus 2. So that looks about right, honestly. It might be an 8-inch. I want to say it's a 7-inch. So now you'll notice that although this is correct as far as the offset, it's not correct to where the ball joint really is, which is down here somewhere. So to do that, and it's not going to be easy, we need 4.5-inch offset. So I believe I can do an offset lane that's 4.5-inch. That didn't come out right. And what would be the best way to do this? Okay, let's do this. Let's back up. Create sketch. And then from that sketch, we are going to draw a line that's 4.5 inches. Okay, and that seems to look about right, about comparable to what we were seeing with the car. So now we need to finish the sketch, and then we're going to create a new point right there. Okay, now we can hide our first point, we can hide our sketch, and we can go ahead and finish off the wheel, which was 5-inch extra tire there. Okay, so now we have our proper control point. We can save it as rally wheel and tire. Okay. So we can close that. Now we can create a new, a new design. So what we're going to do, we're going to use offset planes simply because this will make this a lot easier. So we're going to create a plane here. Okay, then we're going to create an offset plane that is 10 millimeters out. Okay, and then we'll create a plane that is 62 millimeters out. Guys, if you guys have just finished watching the previous video, you'll understand what I'm doing. 10 millimeters out. Then it is 264 millimeters out. And then it is 45. Okay, so this is the simulation of the vehicle's mounting. So this is our subframe. This is our, let's call it a caster block. I don't really know what the proper term is. Now, we want to create a work axis perpendicular at point. So, no, shit. Axis perpendicular to face at point. What the f is going on? Okay. Might be a little harder. Yeah, some of these drawing tools are kind of a joke. Like you can't even create. Oh, it's annoying. Point. Can I just create a point on the origin? Like, why is that? Oh, man. Okay, how about? Okay, choose the origin and then the. That's really annoying. I've had trouble with this before. We'll have to come back to it. Okay. So then we want to create an offset plane that is, where's the piece of paper? 365 millimeters out. So 365. Okay. And then 22 millimeters from there. So I might have to create a sketch just to get what I want out of this. So not really behaving like I had hoped. Line there, there, there. Should be able to do this whole thing with these construction planes, points, and lines, but this software has some very frustrating limitations that really aren't necessary. They're just, they just don't want to add the feature that's been standard on other CAD programs for a decade. Okay, we're going to call that 10, and that was 62, so we're basically doing the same work twice just to fix the limitations in the software. 10, this is 264, this was 5, okay, this is 365. Okay, and then we need a line here that is 22. Okay, so I know this doesn't appear to make much sense right now, but it should hopefully. We're going to call this. Just ignore that. That's something for me. Okay. Now I can come back and create the axes that I wanted. create an axis through here, here. Okay. Then I can create work points here, here. Whoops. There. 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 Finally. Here. And here. And I want to go down and create a point here. Okay. So now I should be able to get rid of that sketch. And then I can get rid of this construction plane. The others I'm going to leave, and I think I might have to keep that axis for now. So now what we're going to do, we're going to come in and start working on simulating the wheel and tire and control arm and everything. So we're going to bring in our wheel and tire. Okay. Then we are going to create a joint revolution. It's going to be this to this. Oh yeah. Okay. Then what we're going to do is I forgot to measure it while it was on the car, but I did some basic math for the turning circle and estimated the steering angle based on the turning circle, which in this case is, let's see, it's going to have a minimum of 45. I think 45 is actually too much, but a maximum of 45. I think the calculation was more like 40 degrees or so. I really screwed up. I basically going to have to go back out to the car and probably have to put it all back together to measure my steering angle properly, but this is what we've got for now. So do 45 degrees, worst case scenario steering angle, save. So now we're supposed to be able to drive this joint. There we go. So we put our wheel and tire in the worst possible configuration, and that kind of gives us an idea of where we can and cannot run our control arm. Okay. Oh, come on. Stay. There it is. Okay. Now to draw the control arm is going to be a little more complicated. So we need to bring in our Heim joints. And for now, we're just going to assume I'm going to use the industry standard Heim joints that are used in most off-road custom suspensions, which are half inch inside with a 5/8 by 18 thread. It's a really big, beefy, very strong joint. So yeah. Then I need another one. So it brings it in at the wrong angle again. Okay. Drag it over for now. And then we need to, come on. Okay. So now we need to join these and make sure they're rotational. So we grab the center of this And we're going to stick it here. Oh. That's not good. It's the wrong. Oh boy. Can I select the axis? No. Shit. Well, that's not good. Okay, what about that? It's not letting me. That's a problem. That is a problem. If I did a rigid joint there to there. Shit. Great. Great. Oh, man, see, I didn't want to have to. I didn't want to have to do it the hard way. God, that's shit. Okay. There's got to be a way to. Alright, let's do this. Do planar from here. Wait, I can't select a plane for a planar joint? What? Planar joint. You've got to be kidding me. Why? Oh, that makes my head hurt. Of all the stupid. Oh. Yeah. Okay. So. That really makes me mad. We're gonna go -10. Okay. Then as built that. Oops. I'm gonna lock this. To the origin. No, that's not working either. It makes me so mad. Okay. Alright. Let's same thing. 12, 20. Okay. Extrude. What was it? It was 5. Where'd that plane go? Okay. So now we have those two features in there, which is, yeah, I think I can convert them to, yeah, create component. Okay. So then we do the as-built joint, which is this component rigid to the origin. Okay, as-built joint. Rigid to the origin. Okay, there we go. Now we can do our moving joint, which is the revolution of that to that. Okay, and for now we're not going to put any kind of spacer or anything in it. Although we probably would need one. I don't know if it'd be a good idea to center it here, but this is what we'll do for now. So, okay, we'll do that. Now this one, same thing, joint from here to here. Okay. Let's get, where's the wheel and tire? Let's get the wheel and tire out of my way for a second. Okay. Save. Yeah, I really screwed up by not measuring the angle of measuring the steering angle. Kind of not good. So anyway. Alright. So now we have to add our tube end weld nut. Okay. Another one. And so what this does is this adapts the threads to the tube. In this case, we're going to be using some pretty large 1.5 inch DOM tube, which is very strong, twice as strong as what they've used for the factory stuff. So it's going to be okay. So that it's going to be attached. Don't give me shit today. There. Okay. This attached there. Okay. Before we start drawing, I need to set joints. Where's joints here? For edit limits. Okay. Edits. So that way they can't spin for the time being and mess everything up. Okay. So now we have the location of our ball joint, which is basically straight on this tube, which is not good. Something I'm not sure how I'm gonna deal with, honestly, because we need to have a full piece of tube supporting the ball joint, and that's not gonna happen with this. But what we can do is we can create a simple simulation to kind of simulate the shape that we want. So what we're going to do is start a sketch. Then we're going to project this. Let's see. 0.7. Okay. And we're going to project that and that onto the sketch. Okay. So then we can go ahead and simulate our DOM tube. So what we'll do, we determined the ball joint was a 42 millimeter ball joint. Then the DOM tube is going to be a little harder to simulate. But we don't have to, luckily we don't have to simulate all of it. We just have to kind of, well, you'll see. So we're going to do that, and then we're going to have to project that and that. Okay. Then we're going to limit this to there and this to there. Okay. Then if you come back and look at our tire and wheel, oof, yeah, doesn't look so good, does it? I mean, the tire is right there. It really makes me think I'm gonna have to go back and reassemble the whole car back together so I can I really don't want to do that though. So I can measure the steering angle. I might be able to just measure the steering angle on the right side of the car because this 45 degrees just, man, it does not give me hope. Like if I say 40 degrees, um, it still doesn't give me much hope. Wow, it's really concerning. Anyway, okay, hide the wheel and tire again. We'll have to deal with that later. So we have, and I can always 3D print the A-arm in full size and install it on the car. I mean, it's not going to hold any weight, of course, but it might help me determine if, you know, we've got a problem or not. So, yeah, so we got this, and we've got this. So the only thing we need to do now is just bring this out to like, well, we're only going to be able to, the ball joint, you'll see whenever I have to do the ball joint, but um, we're going to do this to there. Okay, finish. Now we're going to extrude just this piece. Oops. Symmetrically, and the whole length is going to be 1.5 inches. And we're doing a new body, so it's an independent body. The only thing we need to worry about is this face here, so create a sketch. And we're going to project this and this, okay? And then finish sketch. We're going to extrude that to match. Oh, that's frustrating. Oops. We're going to cut it in 1 inch to match. So, okay. So, this looks odd. Like, trust me, I know it looks odd, but it will tell us a lot of information that we need to know. One of the things we need to do first is grab these two edges, 0.5 inch. Okay. Ooh, that wasn't right. Hold on. Oh, yeah. 7.5. Okay. Save. Now we should be able to go straight into our simulation. So shape optimization, create study. No, that's not gonna work. Delete study. Cancel. Okay, sorry. We're gonna have to. Thought there was a way to keep certain components out of the study. Maybe not. Alright, we're gonna have to try it this way. We're gonna save a separate file. And then we're going to come in and it's referenced. Oh boy. Should be a remove option. There it is, remove. I have to break the link and remove. Remove. Break link. Move. Break link. Move. Break. Remove. Okay, so we're just left with this, you know, really weird looking piece. Now we can go to simulate. Create study. Okay. Material will be, I believe it was 1020. Yeah, it was 1020 hot rolled. Okay, so we're choosing our steel. Now our constraints will be this and this will be fixed in place. Okay, then our force will be in pound force. Let's see. Oh, that's the wrong direction. I think we want it this way. Yeah. So we're going to do half the weight of the car, or 1,500 pound force, which is way more than this will ever see, but we're just going to do this for the simulation. Okay, save. Now we want to go to settings, mesh, 1, 2, 3%. So it's going to generate a mesh real quick. Normally real quick. Okay, there. So now we have all these little pieces that it uses to simulate. Then we solve, and I wish I could solve it locally. It won't let you solve it on your own processor. It makes you solve it on the cloud, which is bullshit. Because eventually you have to start paying for cloud credits. In this case, it's $1 per credit. So it would cost me $5 just to run this test simulation. Not even the final simulation, it's just a test. So that's really frustrating. But it's free for now, but it won't be forever. So I would really hope they add the local option. Anyway, we're going to run it on the cloud. Should solve pretty quickly. Okay, so we're back. So you can see, just like I showed you earlier, it gives us the same general shape. Unfortunately, this shape would interfere with the wheel. And I can probably show you that there's a way. Like that. There we go. Okay, so we now have our what's considered optimal shape. And I think we can actually drag this optimal shape back into the main. First, let's kind of clean this up a little bit. Shut all this crap off. Save. Okay. Go back to version 1. So now we can actually get rid of this body. It's not necessary anymore. Sketch 5. Okay. Save. Then we bring in our. What is this one? What? Oh, wow, I'm very confused now. Oh, shit. It's not supposed to be that difficult. What is the deal? Results. Convert. Oh, that's why. That's why. There we go. There we go. Save. Okay. Now give it a sec. Now we bring it in. There's our optimal design control arm. But look at that. Your wheel and tire is right there in it. And again, I'm still a little not understanding of if I have the steering angle right. because obviously 20 degrees is completely wrong. But say the car can only steer at 30 degrees. Well, then I don't have to deviate from my shape too much. And you have to, I don't know, you have to miss all of this here. So it's going to be kind of a pain to figure this out without going back out to the car. And yeah, great. Great, just great. I'm gonna have to go back out to the car and get my steering angle figured out first. But I know that we're gonna have issues with all of this, so it's gonna be tough. It's gonna be very tough. Let's see. And the other problem is, the center of the ball joint is just, I don't know. It's going to be an issue. Well, it almost needs to be over here with the two pipes behind it, but I don't think that would be strong. So, and I can't put the Heim joint directly up against this because it won't have enough room to pivot. There's a little bit of math you can do to figure out how much room it needs and just move it over a little bit. And same for over here, take this one and move it over a little bit. Granted, this one isn't the right size for this. So, but yeah, I'm gonna have to go back out to the car, measure the steering angle somehow. I don't even know how I'm gonna do that. And then I will come back and update our wheel and tire simulation so that it's correct. Okay, so we're back, and based on the measurements I took, it looks like about 32 degrees, but we're going to be a little safe and we're going to do 35 degrees. And I think I'm just going to have to suck it up and 3D print a mock-up to make sure that it clears. Granted, I don't know how well a 3D printed mock-up would withstand even turning the wheel, but figure that out later. So, Alright, so we've got the wheel at 35 degrees. Now you can see that still leaves us with quite a bit of a problem. So what we're going to do, we're going to get this out of our way. And we're going to do what we did before, which is we're going to create a sketch. Okay. And then we're going to hide our wheel real quick. And we're going to project that, and that. Okay. It's going to be a little more complex this time, so just have to bear with me. We are going to draw our circle around the ball joint at 42 millimeters. We're going to take our rectangle. I'm just going to draw it out here for a sec. Okay, and we're going to align it back up like we did before. There to there, there to there, and here to here, here to here. Okay, now we have to make a clearance for the wheel. And if we kind of look at this design here, you can actually see it left space here. So wherever this hole was, basically, it left space for it, which I won't pretend to understand why, but so we're going to have to do the same thing. So what we'll do, we know we have a 1.5 inch pipe, So we're going to draw a line. Hold on, I gotta project this. We're gonna draw a line. It's going to be 1.5 inch to simulate the pipe size. And then it's going to come over here, and we'll have to do a little math, but we're going to do 2 inch for now. We'll come back and fix that later. Then we need to turn our wheel back on. You can see we're already very close. And we might have to tweak that a little more. Let's do 1.5 inch. Okay. Now what I'm going to do is I'm going to draw an arc. And it's just going to kind of sit here for now, and it's going to have a 5-inch radius. That's because a friend of mine in town has a pipe bender, and he believes it's a 5-inch radius. If it's not, we can always come back and correct that later. But for now, that's what we're going to go with. So we are going to connect this to here. There's no, well, I guess we want a tangent so we can kind of see what I'm doing. Okay. And then we want to do the same down here. We want this pipe to clear the wheel just enough to basically have room. And what we're doing is we're going to have to draw a line here. And then the dimension will be, it will have to be 3 inch since we have two 1.5 inch pipes coming together. So for strength, we want both pipes to be fully formed. Okay, so then we're going to dimension this off. Again, we want to leave some space, so maybe 1 inch. That's probably not enough actually, because the pipe's gonna. Okay, let's do it this way. Let's draw the line from here to here, and then tangent that line down to the edge of the ball joint. So the pipe will extend pretty much to the edge of the ball joint. Again, there's some tweaking we can do on that to allow for welding space and things like that, but that's what we're going to go with. And then we're going to bring this line down here, and it's going to tangent to here. Okay. So now I need to change our display settings to wireframe. So see there, actually that doesn't help me much, does it? Sorry, let's go back to Yep, we're just gonna have to do it this way. So we can see that we have a contact here on the barrel of the wheel. And we can kind of move. So what we want to do is we want to develop the strongest possible link that doesn't contact the wheel. But then, of course, we need, well, what would happen if I projected this onto the sketch? And then if I put a point, I can't do an intersection point. Just zoom in really far and just guess it. And lock it in place. And then do the same over here. Just come in, zoom in really far. Kind of guess that point. Lock it in place. Okay, so now we can actually turn the wheel back off to get it out of our way. And we've got our 2 points. So we want, the original vehicle had a, what you would call, I'm not really sure how to describe it. It had a, can I dimension that to that? can. It was a 1 3/4 inch clearance, so let's say we do a 1 inch clearance. Let's say we tighten that up. And then this one would be the same, so we would do, oof, that's not gonna work. There we go, we do 1 inch. So we're giving ourselves 1 inch around. Okay. Then we're coming down here like this. Alright, so finish sketch. Gonna save. Now we're going to extrude this profile, this piece, and this piece. Okay. And we're gonna, ooh, I made a mistake. Well, you'll see here in a sec, but symmetric, total distance, 1.5 inches. Okay. And then we're gonna come through and do our radiuses so that everything, ooh, that didn't turn out like I wanted. That's also not really what I wanted, but how can I fix that? That should be pretty simple to fix, actually. Create our sketch. We will, come on, project that and that. Okay, and then we're going to hide them. So we can then fix that. First thing I'll do is take this and, whoops, extrude it out. What did I do, 2 inch? No, 2.5. Well, okay, that's a little confusing. Hold on, we're gonna have to go back. Back. 61.9125. Okay. There we go. Okay. So that basically simulates the tube, this tube, running into this tube. I actually, crap. Nope. Okay. You guys kind of see where I'm going with this, hopefully. So, and it's actually kind of looking like the original, which I don't know if that's encouraging or not. So, let's see, we've got that, we've got this, and, oh yeah, and then I need the holes, so we gotta go back to these sketches, and they just go down an inch, -1 inch. Okay. I can unhide these. Okay, now I'm gonna override. Well, actually, no, I will not. I will save it as totally new one. And we have to go through the whole process again. We have to break, remove, break, remove, break, remove, again and again and again. Okay, so now we're only left, and we'll turn off all this construction crap. And there's a sketch that's on. Turn the sketch off. Okay, go back to number 1 for a sec so I can turn that sketch off that I left on. What? Crap, something's going on. There we go. Okay, sketch off. Okay, and then, oh yeah, so the thing, yeah, got pretty good amount of room there. Let's see if it'll tell me what the minimum distance is from here to here. 14 millimeters, half an inch. Wow. Probably too close, especially for suspension flex and, you know, oof. But it's a prototype. Okay. All right, save. Hope assuming this is assuming that it's a 5-inch radius. If it isn't, we'll have to come back and redo all this. But anyway, okay, close this. Go back to here. Now we go to simulation, optimization. Why did it turn all that shit back on? Okay, and so what we're gonna do, materials, we're gonna do steel, and it was 1020 hot rolled, okay, because steel, different types of steel have different properties, of course. So constraints, fix there and fix there, okay. Save this again. And then the load, we'll do the same load as before of 1,500 pounds. Whoops. 1,500 pounds. Okay. Double check that. What is the deal? Okay, 1,500. Okay. 1,500 pounds. Save. Now we gotta set up our mesh to 3%. Okay, generate. It's sad because I'm pretty sure my processor on my computer is faster than Autodesk's servers. So, yeah, it's frustrating that they solve it for me and I can't just solve it myself. So we're going to go to solve. It forces you to do it on the cloud. We're going to click solve, and then I will come back when it's done. Okay, so we are back and it's done, and it's basically telling us, it's telling us that we want, oh, wow, that's a lot more complex result than I expected. It is a much more complex result than I expected. So it's, go back. So it wants us to connect wow. So it's basically saying, trying to understand these results. It's basically saying it doesn't want us to have this extra here for whatever reason. But why? So it wants me to distribute the load as close to the joint as possible. And then up here it wants a cross brace from here down to here. Interesting. How would I design this the way it wants? Now this would be all solid tube, and then it would come up and around. And then it makes me think I'm gonna have to use the thicker walled tubing. But then I'd have some issues with these plugs. And it wants this piece here for support from here to here. Okay, close that, go back to this. Okay, I see, kind of see where it's going. So we're gonna have to remove this body. And then we're going to create a sketch here. We're going to project this and this, that, that, project that. Okay. So now I'm going to create the pathways to build the tubing, if that makes sense. Or wait. Hold on. No, I'm doing this the hard way. I'm gonna delete that. Delete that. Delete that. Delete that. And this. Okay. Sorry. Okay. We're gonna keep all this because I actually need it. So I'm going to develop. See, we're gonna project this center and this center. And then we're going to draw a line from here down to where we believe the ball joint is going to end. Of course, we need some room for welding. So that's obviously not going to, that's going to be too much, but we'll deal with that later. And then we're going to, this line's going to have to be fixed. So it basically is saying that it wants me to, oh man, this is going to be a tough one. I'm gonna have to redraw these lines. So this is just a random line. I don't want any constraints on it except here to here is gonna be 1.5 inch. Okay. Then we're going to have a 3-point arc. It's just random. The diameter, the arc is 5 inches. This need to be tangent. Can kind of move the arc around a little bit now. Okay, and then I want a line from here. See, I don't know how long this has to be. I would assume that the line has to be, let's say if it's 1.5 inch, that's probably too short. Let's do 2 inch. It's a 2-inch line. And then it wants this to come up. So we would have to draw a line from here to here, tangent, and then we would want the dimension from here to here would have to be 0.75 inch. Okay. Really, let's do 1 inch. Let's stick it in the center here. Okay. Now we can play with our arc a little bit better. So from here to here we want, let's see, 1 inch, but we need plus 0.75. So let's do 2 inch. We need 2 inches from here, 2 inches from here. Ooh, that doesn't look good. Can't do that. Oh boy. That might be a problem. Okay, try deleting that. Make this perpendicular. Okay. All right. We have that pipe, and this pipe. And then the results. As crazy as that looks, I wanted it from here to, man, I don't know what angle that would be. Let me see if I can guess that angle here. So oh, okay, okay, I see. 90 degrees. So we want a line that goes to here, and then it will have to be 1 inch down, just like this one. Ooh, that's not really working the way I wanted to. I don't really have any other way to do it though. I'm just gonna have to approximate what it wanted. So let's do, oof, no, that won't work. Okay, I'm gonna have to just like half-ass it. Can you do perpendicular to, nope. No, it didn't work. I could just do 45 degrees. I know that's kind of a cliche, but I'm not really sure what else I'm going to be able to do for now. Okay. And the sketch is invisible again. Okay. So now we have to create sketches. I'm going to have to create a point there. Ooh, a plain along path. Did they finally listen to people and add what we wanted? Oh, hey, they did. They finally fucking added the plain along path, which is what people have been asking for this whole freaking time. Okay, so check this out. So if I create sketch and I circle 1.5 inch and sketch, nope, I gotta project it. Yeah, okay. 1.5 inch. Okay. Then I need to create the wall. And in this case, we're just going to go with 0.95 inch, 0.95 inch wall. For now, I probably will have to do thicker wall once I've run the simulation and see if it's strong enough, which I'm already going to guess it's not going to be strong enough. We'll have to do a thicker wall, and then these tube adapters are going to be a problem, but we'll have to deal with that later. Okay, so now what we want to do is sweep this profile along this path. Okay, whoa, where'd my sketch go? Then we want to sweep this profile along this path. You guys see where I'm going with this? Yeah. Okay. We want to join to the original body. We only want one body, otherwise the simulator's gonna have a fit. We got to take care of this problem here in a second. Okay, so now we want to create a plain along path there at 1. Okay, and then want to create a sketch, which is 1.5 inch, and then you want to do, whoops, negative 0.095 inch. I think it was 0.095. Crap, I hope that's right. This is diameter 33.274. 33.274. Okay, good, I did it right. Okay, now what we're going to do is sweep this profile along this path, join. Okay. Okay. And then we have to come back and sweep the inner profile along the path, and we're going to cut it. That way we have a hollow tube in there like we want. Okay? So, got a couple more small things to deal with. Which is this piece here, which almost doesn't even look, necessary. Like this piece here, I don't like how far away it is from, I don't know. It's leaving room for this weld here, but it doesn't really leave much in the way of clearance on anything else. So I could probably go all the way back to, nope, not that sketch. This sketch. If I change this to 0.75 inch and hope the whole thing doesn't explode on me. Same here, change this to 0.75 inch. Finish sketch. Okay, so now it's much more balanced. So see, you have room here for the welding and here, even though it's probably going to get kind of caught up in this weld. And this is a little better. It's still kind of junk, but anyway, so we want a plain along path. No zero. Okay. And then we're gonna create a sketch. And we're gonna do 1.5 inch. And then we're gonna create the offset of 0.095. Make it a 0.095 inch wall pipe. Finish sketch. We are going to sweep this along this path. Join. Okay. So that actually doesn't look so bad. It does tell me that I can go much higher up over here to try and get a little bit more distance. So we're going to go all the way back to here. We're going to do 0.5 inch. Really going to get up in there. There we go. Now it's more even, and we got a little bit more support here. Okay. And oh yeah, we have to go back and clean out the, where is it? Sweep. We got to sweep this along this path and sweep this, whoops, sweep this along this path. Okay. But kind of screws me up because now I have to come back and sweep this one again. Okay. So solid pipe, solid pipe, solid pipe. Okay. Think. Yeah. Okay, so there's our control arm. There's still a couple more things to do. In this case, we need something to connect the ball joint. And so I won't get into it too deep, but there's a very specific way that we're going to have to connect the ball joint, and I can't really be too specific about it until I actually until I can actually get the ball joint in my hand to model it in 3D. But we're gonna basically have to cut a slit, and in this case, if we do 0.25 inch steel plate, so 1/4 inch steel plate, I think that'll be thick enough. Again, I don't really have any way of knowing until till we actually get further along in this. But what we're going to do is we're going to, whoops, go back. We're going to be welding in a steel plate into the tube, and that will prevent any kind of, you know, flexing with the ball joint. So I think this will be 1 inch. So we're going to leave a little to be welded. Oops, I have to project this dimension here to here. Do 1 inch. Okay. All right. We're going to basically just extrude all this together. And we're actually going to join the pipes together like this. The problem is we need to go back and take a look at our wheel and tire, make sure we're not. Ooh, yeah, we're getting close to that wheel and tire, so I don't know, we could do -2 inch. I don't know if 2 inches is enough. Mm, 3 inch. See, I'm not liking that 3 inch. It's getting really close to the wheel and tire. See, I don't really know how much we need for it to be like, you know, do 2 inch for now. Let's see what happens. Okay. So we now have everything joined together. Okay, now we're gonna save as version or part 4. Save. Okay. And had some issues with that before, so we're gonna close everything, reopen. Okay, now we have to do the same shit again. Break link, remove. Break link, remove. Okay, and then for whatever reason, the construction planes don't seem to keep their memories, but alright. Save. Ooh, actually, I probably should have. Damn, it's too late now. What should I do for that? Because it's gonna make a difference in the strength. Well, I'll run the simulation like it is. I mean, I'll run the simulation like it is for now. I can come back and fix that later. So we're gonna go to simulation. We're gonna go to stress, because we're not determining how we want to build it anymore. We're determining if what we built is strong enough. Okay. So. Uh-oh. What's this body 6? What the hell is body 6? What? How did that create a new body? What? Is that body 6? Okay, that's very confusing. Alright, remove. Weird. Okay. That also means I have to fix this too. remove body 6. Okay. Save. Close. Alright, go back to the simulation. And we're going to go with our steel 1020 hot rolled. Okay. Then our constraints are going to be a little different this time. And this is why I'm a little worried about the simulation integrity, but we'll fix it up if it doesn't look so good. So we're just going to constrain them here as if they were welded to those nuts. It might actually be more realistic, but we'll find out. So then the load will be spread across here, which is correct. That's kind of how we're going to end up having to weld that ball joint in. And we're going to go 1,500, whoops, that's in newtons, 1,500 pounds. Okay. Save. Now the mesh, this mesh is probably going to be a problem. Please compute. I'm a little worried if it's gonna have issues with these pipes touching. No, good, the program was smart enough to realize. Oh, yeah. Okay. So now what we do, we go to settings of adaptive mesh refinement high. So it'll make the mesh more and more accurate depending on where in the model the stress is to give us a more accurate result of what's going on. Save and solve in local solve. So this one it lets you do locally, luckily. So you can see, prepares the model, everything's generated, and it's going to solve, and then it's going to solve again, and then again. It's going to solve 6 times to get the best result. So I'm going to pause, and we'll come back when it's done. Okay, so we're back, and you can see that it solved it 6 times, and we get this nice little diagram. And it says the safety factor is 0.26. So I want anything with a safety factor under 2. So anything under 3,000 pounds. So we are actually, and I'm not surprised, this here is not doing well. There's a way to thought there was a way to change the scale. So, okay, if we look at, so this is the original shape and the actual shape. So see how it kind of bends a little bit? And then this is like a exaggerated, kind of showing you what's happening. But this is the actual, which is very little. So basically here we're showing that this part here failed. This part here failed. Okay, well, let's just go down to 1 then. Anything that couldn't handle 1,500 pounds. So really this, which isn't a concern. It almost looks like it. And then this, which is of course just an anomaly. But then everything else is like, I mean, we're talking, that's 3 times, so that's 4,500 pounds. That's 6,000 pounds. I mean, we're talking, and then this, all this is very strong. You can see how this pipe here is actually lessening the stress here. Now, the one thing I don't like is the mesh. See how the mesh isn't very accurate? And it's doing that because it thinks all the stress is concentrated in these little areas. I might have to redo it with a more accurate mesh. Let's finish results, and we're going to have to go back all the way back to design. And we're going to have to actually put these back in. And I know you're like, well, you just removed them, and I know, so you just bear with me for a sec here. So we're going to joint fixed. So we're going to do that to that. Okay. And then do that to that, and you'll see why here in a sec. Okay, this should make the simulation much more accurate, and it's a little harder to calculate. So we're going to regenerate our mesh. Okay, and you can see the mesh size here is really not good, so I'm not liking that. Solve, whoops, settings, where's our mesh option? Oh, wow. Yeah, that's awful. We're going to go down to like 3%. And regenerate the mesh. No wonder it was... There we go. Look at how much... Now this is going to take a lot longer to solve. So what I'm going to do is I'm going to turn off adaptive mesh refinement. Well, do I want 2 of them now? We'll see how long it takes to solve just with 1. Okay. And then... So we have to create a contact. So between these two, and the selection set is going to be in here and here. Oh, cancel? There's already contacts? What? It automatically created contacts for me? I didn't... Oh, that's confusing. Okay. Solve? Locally solve. Oh, wait. Nope, cancel. Cancel. Sorry, my bad. The constraints are wrong. Delete. Okay. Manage contacts. Bonded. Okay. I gotta redo the constraint. Yep, that would have been dumb. To these. Okay. Save. Solve. Local. Solve. Okay, this should go pretty fast, honestly. Scheduled. Scheduled, I said local. Scheduled what? What are you scheduling? Oh, hell. Okay, I'll come back when this is done. Okay, so it's done. So we can kind of take a look now. We just scroll down to 2, a safety factor of 2. You can see that the only part that really... Oh, let's go down to 1. The only part that really failed is right here, and those are just errors in the simulation. Nothing else came close, so now there are some spots here on this pipe that are about 1.5, so 2,500 pounds, something around there. So I would say that this design is more than strong enough to support the to support an off-road, adventure. The problem is we need to 3D model the actual ball joint so that we can properly design the lengths and style of the tube. Basically have to do all this again. It won't take as long since I have some of this, done and ready, but basically these results are good. These results show me that I'm, on the right path. Just gonna have to 3D print a test model to figure out, what's going on with the clearance of the tire, wheel and tire. Hopefully the 3D printed model would be strong enough to actually survive. I mean, I could make a solid pipe. It's a lot of plastic though, but anyway. So if we go back to design, and okay, we can close this, then we can go back to this one with all of our stuff, because I'd have to 3D print this Heim too. So the problem is though, is that this here is actually 18 millimeters. So we need a Heim joint that can use an 18 millimeter bolt, and then we need to add like a spacer for the Heim joint to for the Heim joint to wow, I am out of it today. It's clear. And usually that's like, you just get a spacer that's the same length as this. So, a 6 millimeter spacer, I mean, really not much at all. And that will ensure that you have all the space you need. In this case, the car itself has an 8 millimeter, so you could just go with that. Just do an 8 millimeter spacer, which means that all this will move this way 8 millimeters. And then same here, this will move this way 8 millimeters. Oh, that's actually, that might end up, I might end up having to redo a lot of this. I probably will do it off camera and then come back when it's ready. But anyway, so I kind of walked you guys through how to build your own tubular A-arms from scratch, how to simulate the proper strength, and then how to design the tubes, how to simulate the tubes to make sure they work. Yeah, so thank you guys for watching, and I will see you next time.